So guys, in this video we are going to talk about the variables and data types. These variables are two types: initialized variables and uninitialized variables. These data types are few types: byte, word, dword and quad word. So one byte consists of 8 bits and 2 bytes consists of 16 bits and 4 bytes consists of 32 bits. So this word consists of 2 bytes and also double word. So double the word means 4 bytes, and quad word means double the double word, that means 8 bytes. So totally we have byte, word, d word and the quad word. So we can declare like this: define byte, if you means db means define byte, dw means define word, and etc. So this is a old convention to define the byte. So we can also say temp1 and we can specify the byte. So we can specify say byte 12. So the value of that variable at this address is 12, that is an integer. And what we can do is we can also specify the negative numbers using the s byte. So s stands for signed byte. So signed numbers can be positive or negative, and default it will allocate the unsigned integer, that means only positive number. So if you want to declare a negative variable, then you can say s byte. And now I can say as minus 20. So I can give like this. So now temp2 stores the value of minus 20 and the temp1 stores the positive 12. So that is the s byte. In the similar way you can also declare the word, d word, etc. So let's go ahead and do that. Temp3, and you can say word consists of 2 bytes, right? So we can just say normally a string consists of 2 characters. So this each character specifies requires 1 byte. So 2 alphabets or characters requires 2 bytes. So you can also specify the d word. So these directives can be capital or anything, because this assembly is a case insensitive. You can declare this any alphabet, capital or either your wish. Okay, d word, and we can specify now a b c d. So this temp4 consists of these 4 bytes, which allocates the a b c d. And we can also say temp5, and now we can say quad word. Now we can give 8 characters. So we can say 1 2 3 4 5 6 7 8. So this is a string consists of the 8 bytes, which is the quad word. So temp5 stores the quad word, which of the 64 bits. So these are the initialized variables, because these are getting the value, assigning the values when we are declared. So these are called initialized variables. And now we can also define the uninitialized variables. So for that we need to declare a section called data question mark. So generally normally a uninitialized variable will declare like this. Let's say test, let's say temp byte, and we can press the question mark. So this is the uninitialized variable. If you think of it as high level language, int temp, a semicolon. So that's it, there is no value assigned to it. So we can assign the value in our instructions in our code section. Okay, if you want to allocate 1000 bytes, you can also allocate. Also, okay, I will also show you the array or the list. You can say arr byte, and we can also say 1 2 3 sorry so 1 2 3 4. So I can define like this the multiple bytes pointed to this variable. So this variable r will by default point to this first element only. So if you want to access the second element, you can say r plus 1. So this first element is the 0th index. So you can think like this one is r, and if you add plus 1, because 1 byte offset you will get the second element, and another one you get the third element, another one fourth element. So in that way you can also store the characters, as long as it takes the 1 byte value, because we are declaring this array as a byte. So this is the one way to initialize the uninitialized variable, and you can also place this in the dot data question mark section. The difference is, whenever you compile this binary, the data will be stored in the binary. If you create 1000 bytes, the file size will be like 1000 bytes. So that's why you can initialize all this data in the dot data question mark, so that it will be allocated during the runtime. So let's and now if you want to let's say 1000 bytes, I can just say you cannot write 1 2 3 4 and so on up to 1000. So that's why I can just say t and byte. I can use the directory called dupe. This duplicates, we need to specify how many times you want to declare. Let's say 10 times I want to duplicate of 1. So it's like a continuous array with initialized 1. So t points to an like array 10 elements with all the elements 1. So if you create 1000 bytes here, it will be not in the file size, it will it will get allocated memory during the runtime. So now let's build our solution. So constant value 2 large. So it's okay. I think we are dealing with the 32-bit. Let's just remove this line. So okay, we have got successful. Let's step over the program. So already our data has been loaded into the memory, the variable that is dot data section. This is the first instruction. So you can just go to the debug windows and memory 1. Now you can open this ASM file. Sorry. Okay, now we can check our variables. Let's say ampersand temp1. If you hit enter, you can see 1 byte 0c. That means in a hexadecimal, the 12 will be stored in the hexadecimal as a C, and you can see the temp2, the next byte is EC. So if you convert this EC into decimal, you will get one number, and you need to find the 2's component for that, so that you can get the -20. So that is the EC, and you can see here that EC is stored as a ASCII character, and you can see the temp3 word AB. So 62 61. So 62 61 is the hexadecimal representation for the AB, and the D word you can see ABCD. Those are in the Returnian byte order. That means you can see ABCD because it's in Returnian byte order. In the memory it will be reverse byte order. So you can also say ampersand R. So now we can see ampersand R points to the address that's points to the first element of this array, that is 1, and the next is 2 3 4 and 61, that is the A, that means hexadecimal in that representation of the ASCII. And you can see the temp byte, which is the null byte because it's not initialized, and in the code section if you allocate any memory, it will be placed here, and you can see t 10 duplicate of 1, that means 10 ones of an array. You can see the 10 ones here, that is t. So these variables are placed linearly, and what you can do is you can say ar plus 1. So to access, if you say ar plus 0, you will get the same one because we are at the starting of this one. And r plus 1, you get the second element 2. And if you scroll up, you can see the dump here. So in that way, in the continuous memory, you can access using this offset. So we can also say where, but it will not be initialized now. It will be initialized at the runtime because we are running the program. We stopped at the breakpoint. Now this value can be replaced in the instructions.